Good morning, everybody, and thank you for joining me for this presentation. My name is Joy Weiss, and I'm responsible for IoT and security solutions at Analog Devices. I'll describe a little bit about our company, and I'll talk about the difference between IoT and extreme IoT, and I'll work through some examples of what we mean when we talk about extreme IoT. We're very pleased to be part of this MindSphere partner exhibit. We have a booth just over on the right there where we're displaying with some of our partners capabilities to do wireless access, condition-based monitoring integrated into the MindSphere ecosystem. So we thank our hosts for giving us this opportunity to present to you today. Analog Devices is a company based, headquartered in the United States. And our hallmark really is that we like to partner with our customers to solve the very hard problems, leveraging over a half a century of experience in creating analog, mixed signal, digital signal processing ICs, as well as algorithms, software, and system solutions. In the IoT, of course, what we're really doing is taking information from the physical world and translating it into the digital world. And so our expertise in bridging the analog to digital divide is particularly relevant in helping to solve IoT problems. We have a breadth of products, over 45,000 products, over 125,000 customers worldwide. And our products are known for their performance and value in solving these very hard problems, such as the ones presented by Industry 4.0. We've grown organically and via acquisition. I joined Analog Devices through starting out as the CEO of a startup company in Silicon Valley. That company was acquired by Linear Technology about 6 years ago. And then earlier this year, Linear Technology became part of Analog Devices. I think that's also a story about IoT, is all of the mergers and acquisitions that are combining value propositions to deliver the end-to-end solutions required in this space. So let's talk about basic IoT as a baseline so that then we can talk about what extreme IoT looks like. Basic IoT, you might have some sensor in the field that is sampling data infrequently, might be a little bit of data. It needs connectivity. It needs to be connected in a robust way, but it may be that if you're getting data once a day, it's okay to resend that data periodically. A little bit of data typically, and that can be readily analyzed in the cloud as necessary. But when we talk about extreme IoT, what if instead of a little bit of the data, you had a continuous waveform you were monitoring? What if instead of having a thermostat in your living room, you're in the Arctic, or you're in the desert, or you're in a very harsh environment in a factory floor? This is a very different environment that presents unique challenges to how we solve the IoT equation, and this is what we like to call extreme IoT. Sensing and conversion has to be precise and at the edge of the network. You need the capability not only to process in the cloud, but oftentimes the capability to process data at the very edge of the network. Precision measurements must be taken also at the edge of the network and then also translated up to the application. The connectivity of this network must be robust and have the highest level of security. Oftentimes in these applications, you don't have the luxury of time to resend data that might otherwise have been lost. The reliability and security is of paramount importance for extreme IoT. So let's go through some examples of extreme IoT. In a basic IoT case, as I mentioned, if you're a homeowner and your thermostat, which is a sensor, is sending data to your furnace, if it's off by a few degrees, you just put on a sweater and you've mitigated a system-level problem. If you're in an oil refinery and there's a temperature sensor that's off by even a fraction of a degree, it may be that within seconds or even less than that there is an action that's required for the safety of that plant or for the efficiency of that process to be maintained. It's a world of difference in extreme IoT. So what are the imperatives for the industrial Internet of Things? We must be able to get vital information from hazardous or difficult to access locations. Rotating equipment, for example. How do you get a sensor to accurately collect information and send information from large rotating equipment? In the same environment, the last speaker talked about planning the wiring. Well, what if you can't put wires where the thing is that you need to measure and to that precise point that needs to be measured? This is key to pervasive sensing, the ability to have a completely wire-free option that is robust and secure for the extreme IoT requirements, but is cost-effective and ability to be deployed in any of these extreme environments. Of course, we need precision data and timing for control applications. So the idea of deterministic networking brought to the very edge of the network, whether that be over Ethernet or over wireless technology, is also important. And of course, safety and security are not negotiable. So the imperatives for extreme IoT require a level of flexibility, efficiency, safety, security, and robustness that's much higher level than what's required for basic IoT. Let's look at an example, and this is in our own semiconductor fabrication environment, where we have 175 specialty gas cylinders that we use in the production of integrated circuits. These were previously manually checked every 4 hours for their fill level, and if there was an error, then that could mean lines down in our production capability. We have since deployed a wireless sensor network built for extreme IoT, and we're now automatically collecting data across this very harsh industrial environment that allows us to improve our process, continuous process, reduces the waste because we're now able to precisely know when the gas will run out and use it to the finest level of granularity, and allows us to do capacity planning in a way that we simply could not do when this was done manually. Condition-based monitoring is another good example of extreme IoT. If you visit our booth, you'll see us showing an example of a sensor and wireless combination that can be used for condition-based monitoring all the way up into a MindSphere cloud application. Another aspect of extreme IoT can be things that move. It's hard enough when you've got something that's static, but what happens when the thing in the Internet of Things starts moving around, whether that's a robot or something on the factory floor that may be moving? Once again, in basic IoT, if I'm a consumer and I'm using my phone to guide me to a restaurant, I get visual cues, I get supplementary information, and if I'm off by even many meters in that application, it's not really material to my perception of the success of that application. But if I'm talking about precision agriculture, and I'm talking about the precise dosing of fertilizer or water on a seed, then precision means everything to that application. And the ability to have precise location combined with meticulous sensing is a requirement for extreme IoT that oftentimes does not exist for basic IoT. In the automotive world, similarly, if the traffic information is a little bit off, it may take me a few extra minutes to get where I'm going. But if we're talking about an extreme IoT application under the hood that I'll show you next, then if you're looking at the state of the batteries in your electric or hybrid vehicle, there's no room for error in that calculation. One of the things that we've been working on at Analog Devices is the ability to have the communications between the batteries in an electric vehicle or hybrid vehicle and the controller in that car be done wirelessly and securely. We already have the world's leading battery management system chips, which are precisely measuring the temperature and voltage in that environment, but now we're able to connect those wirelessly, which reduces the weight, increases the safety, and also one of the value propositions about IoT is when things get smart and can talk, there's all kinds of things that you can do that you simply could not do before, all the way from production to the retirement of those batteries. Another example is in the rail environment. Here's a combination of things that move, but also a harsh environment, such as a factory with all kinds of metal. In this application, our customers are measuring a variety of different parameters on a moving rail car so that they can track the asset and the asset health and communicate with it to see if a door is open or if the temperature of a refrigerated vehicle has changed in motion. So in summary, the imperatives for extreme IoT require the highest level of data integrity at the very lowest power to ensure that anything you want to measure, anywhere it may be, can be measured and that that data can be communicated effectively. We need to be able to precisely and effectively transform those signals to solve challenging measurement problems. We have to be able to optionally have localized intelligence and decision-making in addition to cloud-based analysis and decision-making. We need reliable and highly secure connectivity for extreme IoT applications to be successful, and the very best data to the secure cloud. In summary, please come visit us at the Analog Devices booth on the right here, and we'll show you what we mean when we talk about extreme IoT with real examples of sensing, measurement, and connectivity technologies. Thanks so much for your attention today.